Welcome to Cooking in Calculus with the Cressmans. Today I will be exploring the topic of pie while baking an apple caramel pie and explaining how researchers used the Taylor series and the Newton-Raphson method to approximate the number pi. People have been trying to calculate pi for over 2,000 years, and real accuracy was not truly achieved until the use of the infinite series techniques. For example, it was discovered by James Gregory several hundred years ago that pi over 4 equals 1 over 1 minus 1/3 plus 1/5 minus 1/7, and so on. After 626 terms, pi is finally narrowed down to 3.14, or 2 decimal places. This shows that accuracy in models using infinite series is limited by the amount of terms researchers are willing to use, as well as how quickly the series converges. Before getting into how the researchers used an infinite series, in this case a Taylor series, it is first important to know what the Newton-Raphson model is. The Newton-Raphson method is a method for finding successively better approximations to the roots or zeros of a real valued function. It works like this. Say we have a function f of x, this curve here. We guess a point on it, a, and find our next value, b, with the formula b equals a minus f of a over f prime of a. Using this tangent line, we get point b and substitute b in for our next a value, and continue doing this until we reach values closer and closer to the root of f of x. Using the function f of x equals sine x, we know that one of the roots of the function is pi. Using the Newton-Raphson method and a rough initial estimate for pi, such as 3 for example, just 3 iterations of the method will give us pi with accuracy up to 15 decimal places. Unfortunately, most computer programs can only be accurate up to 16 decimal places, so a more manual method is needed to further approximate pi. Researchers chose to continue with the same method, but to manually solve for sine x with the Taylor series. The Taylor series for sine x is shown here, and is one we are all familiar with. Its radius of convergence is all real numbers, and in this particular case, the researchers centered the series at 1/2 to make it converge faster. Approximating using the Taylor series value of sine x centered at 1/2 calculated to the first 15 decimal places. The first 3 iterations of the Newton-Raphson method are as shown. Accuracy in each iteration can be determined by comparing the alike decimal values in the next iteration. The first and second iterations are only alike to the first 3 digits, but the second and third iterations are alike to the first 8. This means that the first iteration was accurate through 3 digits and the second was accurate through 8. Additionally, this can be used to determine how many terms should be used for each iteration to determine the next digits of pi. The formula 10 to the negative k equals x to the n over n factorial can be used to determine the number of terms n the next iteration of the Newton-Raphson method should include to further approximate pi to a certain number of decimals, k. What the researchers realized, and what you too are probably realizing, is that to achieve true accuracy to thousands, millions, or billions of decimal places, an incredibly large amount of iterations are needed with increasingly large amounts of terms to approximate pi in each iteration. In reality, this is simply impractical. For that reason, this research is not particularly important to the study of pi as submitted by the researchers themselves, but it is an interesting exercise if you enjoy pi and calculus.